Message queue. Message queue. Yeah, what is queue? Queue is first in, first out. You know what state? Yeah. So queue is first in, first out. Stake is first in, last out. So we know the example of queue. If you go to mall or theater or anywhere, anyone going first, they will be get come out from first. Stack, that's also used in memory side. The first in, last out. So last will be greet first out. Uh, so message queue here they're having the data. The data structure through the task or ISR, interrupt service routing, communication with each other by sending and receiving message with the synchronization with the data. So consider the memory, the box queue and the name ID. That's the queue length they shown. The maximum message length will be how much they shown in that place. The waiting list of sending part waiting list of data they waited in the place the after entering the queue. Then they will be come out from the queue. The waiting list for receiving text. So the T means text here. The waiting list for sending T1, T2 like that. Once it will be entered into the queue, then it will be come from out of the queue. Waiting list from receiving the text. Mailbox. Mailbox are much similar to messages queue. It's mainly used, it is a one-way messaging. Uh, the mailbox RTOS, you can create and write, read from the mailbox. Also, you can destroy if it is no longer needed. Okay, so mailbox is similar to message queue. Is used one-way messaging. The function of RTOS, real-time operating system, it can to write, to read from the mailbox. Also, if the message is no longer needed, it can destroy. And next one is pipe. Pipes are objects created for unstructured data exchange between tasks and facilitate sync among the tasks. So pipes are object created for unstructured data, and the data will be exchanged between task and another task. That means synchronization between the task, and that will be facilitated. Facilitated means it will be smoothly move between the task. So undirectional data exchange, the task one, and there is a task, and then that writing data to pipe, then another task reading data from pipe. So sending descriptor, sending through the pipe, the data stored in the pipe. Then when pipe is created, two descriptors are created. When pipe is created, two descriptors are created. Then it will be go inside. Then you will be get the reading data from the pipe. Next one is priority inversion. Priority inversion. You know what is priority? Priority is based on scheduling. So which one is first? The task will be go for execution. That is called as priority. So high priority, low priority, like that. Priority inversion. Totally, the first priority will be come to last priority. Last priority comes to the first priority. So that is called as priority invention. There are two types of priority invention. One is bounded and unbounded. So this two task is single source. You can the priority of the time task has lock and shared resources is called task critical section or critical region. So priority task H bounded priority inversion. That white uh, mm, box we can call as a normal execution, and green is critical section execution. So normal execution it's going task high. For task low, the critical section is also going. So see, there is a boundary priority inversion. So it occur when low priority task low and lock on the source resources. But before releasing the resources, is prompted by high priority task. So similarly, the worst case, the task high is equal to the length of critical section of task L. The bounded priority inversion won't generally hurt on application provided in critical section of task low and it executes in timely manner. You can see task low, task medium, and task high. That we already know the normal execution and the critical section execution. That's a green. They put it and then unbounded priority inversion. Okay. The task medium priority task inversion and low priority executive critical section and it releases the shared resources. When task L releases the resources and task H can finally accrue the resource and resume the execution. The worst case, the wait time for task H is now equal to the sum of worst case execution time of task M. So the task M run indefinitely, neither the task L or not task H, and the opposite to resume execution. See, there is a task 1, 2, 3, 4. One of the resources that is blue and waiting of the resources that is orange color. So the resource A and B and C. So actually the task 1 waiting resources, but based on the priority, task 2 went to the resources A, and task 3 went to the resources B, and task 4 went to resource C. But task 1, that priority inversion, it's waiting the task 1. Uh, then see that task A, task B, task C. So here also the resource 1 and task A consider as a resource 2 and task B it will be go to resource waiting of resources that is orange color. Owner of resources is a blue color. Deadlock. Deadlock is special case of resources when the circular chain of tasks waiting for the resources is prevents all the tasks in the chain for the execution. And priority inheritance protocol. Okay, it releases resources once its resources release the task drop back to its original low priority level and permitting the high priority task to use the resources as just accrued. That priority doesn't change. There is no added overhead and here the simple priority inheritance, the normal execution and critical execution, that region A then will be executed parallelly. Some of the execution time of all nested resources will be locked. The priority of design application so that deadlocks can't occur. So, so this is the three task one resources priority inheritance diagram. So how the three task and one resources priority inheritance shown in the picture, and similarly three task two resources priority inheritance. The previous one is three task one resources, and this one is three task two resources priority inheritances. So these are the task level how they will be prompted. So totally, that priority inheritance is totally finished. In that graph shown how it will be flow from level 1 to level 13. So that is they written here. This they discussed here. And then thank you.